Hello everyone, I'm teacher Gohar Huang. Today, I'm going to introduce to you the Unit 8, Independent Sample T-Test. When do we use Independent Sample T-Test? It's used to compare whether there is a statistical significance between the means of two different groups. For example, we might want to compare the heights of males and females to see whether there is a statistical significance. When conducting an independent sample t-test, we must observe two values, the p-value and the t-value. If the p-value is less than 0.05, it indicates significance, referred to as one-star significance. If the p-value is less than 0.01, it indicates stronger significance, referred to as two-star significance. If the p-value is less than 0.001, it indicates the strongest significance, referred to as three-star significance. Additionally, we can observe the t-value. A t-value greater than 1.96 indicates significance. This is an example. We'll first input the data into Excel, then import it into SPSS. Once imported, we can perform the analysis. Under the Analysis tab, there's a method called Comparing Means Analysis, within which there's an option for an independent sample t-test. Once selected, we begin grouping. Independent sample t-test can only compare two groups, which could be based on gender or class. In this example, we are using classes, so we select class. Then, we press the button and define the groups. Since classes in the Excel file are labeled as 1 and 2, we define the groups as 1 and 2. If we were selecting gender, and the genders in the Excel file were labeled as male and female, we would define the groups as male and female. Then, we proceed by clicking Continue. Next, we select the variable we want to analyze and move it to the right-hand side. Assuming we want to analyze the average cognitive load, typically, we would calculate the average of each dimension beforehand. This can be done by using formulas in Excel to prepare the data. Then, we select the averages of these dimensions to the right-hand side and click Confirm. The results of the independent sample t-test would appear as follows. First, let's examine the descriptive statistics. Control Group 1 has 34 samples with a mean of 2.7059. Control Group 2 has 29 samples with a mean of 3.6121. From this, we can infer that Group 2 has a slightly higher mean compared to Group 1. But to determine if this difference is significant, we need to look at the results of the independent sample t-test. Firstly, we need to check if the variances are equal. We assess this by looking at the significance level. If it is greater than 0.05, it indicates insignificance, suggesting that the variances of the two groups are roughly equal. Now, looking at the row corresponding to the test of equality of means, the p-value is 0.000, which is very low. Therefore, it's marked with 3 stars, indicating high significance. The t-value is 3.692. This indicates that there is a significant difference between the means of Group 1 and Group 2. If the significance level is less than 0.05, we cannot assume equal variances. In this case, we would refer to the row below. But in this example, regardless of whether we consider equal variances or not, the results are significant. However, the t-value may vary slightly. After completing the interpretation, we generate a table. As mentioned earlier, the result received 3 stars, indicating a significance level. The t-value is recorded as 3.692 and 3 stars are placed beside it. In the annotation column, we explain that 3 stars signify a p-value less than 0.01. Next, we include the sample size, mean, and standard deviation, ensuring uniformity by rounding to 2 decimal places. That's today's introduction. If you have any questions, please discuss them with me. Bye-bye.